As the melodious strains of a distant saxophone drift through the evening air, we find ourselves captivated by a physics phenomena. Just imagine standing on a street corner, the city lights shimmering around you like a constellation of stars. As you close your eyes, you become keenly aware of the world in motion. Each passing car and bustling pedestrian streets. I want you to feel the Doppler effect while you meditate with physics on your mind. The Doppler effect is defined as the apparent change in frequency of a wave in relation to an observer moving relative to the wave source. Throw away the definition if you don't understand it. Let me make this simpler. The effect is named after the Austrian physicist Christian Doppler, who described the phenomenon in 1842. The noise of the siren of an ambulance or a car speeding past you sounds higher in pitch as it gets closer to you, and it gets lower as it moves away. This is called the Doppler effect, where wave changes in frequency and wavelength as the source moves towards you or away from you. There is no actual change in sound. The sound could be heard different in pitch due to the car's movement relative to you. Let's take another example. When you watch a Formula 1 race, you hear a very high-pitched sound when the car shoots off through the close camera, and then it steadily depletes as the F1 moves away from the camera. The motion of the car compresses the siren sound wave, moving the crest and the trough closer together, and so increasing the frequency of sound. This changes the pitch to a higher one. When the car recedes, the crest and troughs are spread further apart from each other. Coming to the curious question, how do we detect the motion of stars? How is it that we know how fast stars and galaxies are moving towards or away from us? How can we know how fast a star is rotating? One of the greatest astronomical discoveries of the 20th century was the expansion of the universe. How was that uncovered? The answer to all these questions is the Doppler effect again. But in this case, we consider EM waves, not sound waves. If you are an observer and a star is moving towards you, then light waves produced by the star in front of it would get compressed, producing a higher frequency of light waves. A blue light corresponds to a higher frequency wave, so we call it blue shift. If the star is moving away from an observer, then we call it redshift, because it corresponds to the red light having the lowest frequency and is towards the red end of the spectrum. The observation of astronomers concludes that the gap between our planet and the stars is increasing, which means the universe is getting bigger and bigger. And we detect this phenomena through the Doppler effect. The redshift tells us the relative distance between the Earth and the distant stars is increasing. Edwin Hubble, an American astronomer, was the first to notice that the universe is expanding, but before him, scientists imagined our universe to be static. The Doppler effect can also be used in certain circumstances to determine how fast a star is rotating. It was so helpful in physics as well as in medicine, in echocardiogram, ultrasonography, etc. So this is Doppler effect, my friends. See ya.